February 24, 1943 did not arrive with drama. There were no trumpets, no sudden realization that history was about to shift. The morning came hot and heavy, the kind of suffocating heat that clung to the skin before the sun even fully rose. At Port Moresby, the air already shimmered as Lieutenant Clyde Guessel stepped down from the C-47 transport, his boots striking the coral dust runway with a practiced precision that marked him as an engineer first, a soldier second. Around him, the Pacific War continued its relentless rhythm. Distant engines droned overhead, radios crackled with half-heard warnings of enemy raids, and mechanics swore under their breath as they wrestled with battered Allied fighters that never seemed to stay intact for long. Guessel had seen this scene too many times. Since October, as part of the Allied Technical Air Intelligence Unit, he had been flown from one crash site to another, cataloging twisted wreckage and filling out reports that all ended the same way. Japanese fighter. 0 type. Capabilities unknown. It was a classification that satisfied paperwork but made no sense to anyone who actually understood airplanes. Engineers learned early that design told the truth. Every rivet, every curve of a wing, every compromise revealed how a machine was meant to fight. You didn't beat an enemy by pretending all their aircraft were the same. That was why the telegram waiting for him on the tarmac felt different. Only 43 words, sent from Australian infantry advancing through the mud and jungle of New Guinea, but every line carried weight. Buna Airfield cleared. Multiple Japanese aircraft wrecks recovered. Request immediate technical evaluation. Possible new fighter type. Possible new fighter type. Guessel folded the message carefully and slid it into his pocket. He had learned not to get excited too quickly in this war. Too many rumors had turned into disappointments. Still, something about the phrasing stuck with him. Infantry didn't speculate about aircraft types unless something looked truly strange. The jeep ride to Buna took more than 3 hours, crawling along jungle tracks that barely deserved to be called roads. Burned-out pillboxes and abandoned supply dumps lined the way, silent markers of a Japanese retreat that had been brutal and costly for both sides. As the vehicle bounced and lurched, Guessel reviewed months of combat reports in his mind, patterns he'd been piecing together long before anyone in command wanted to listen. British Hurricane pilots over Burma had described enemy fighters that seemed to turn inside their own shadows. American P-40 crews in China spoke of aircraft that climbed like they were pulled upward by invisible hands, yet shattered when hit by even light gunfire. Dutch pilots flying Brewster Buffaloes in the East Indies had radioed frantic warnings about Japanese fighters performing maneuvers no training manual could explain. Hammerhead stalls, impossibly tight turns, right before their transmissions went dead forever. The propaganda said Japanese aircraft were crude, lightly built copies of Western designs. Inferior. Disposable. But the men who actually fought them knew better. These weren't clumsy machines. They were doing something different. Something the Allies didn't yet understand. When Buna Airfield finally came into view, it looked less like a victory and more like a scar carved into the jungle. The single runway was pocked with bomb craters, the control tower abandoned and shattered. Australian infantry had been thorough. 5 Japanese aircraft wrecks had been dragged clear of the runway and arranged roughly in a line, as if someone had instinctively understood their importance. Guessel knew immediately that these weren't the carrier-based fighters from Pearl Harbor. Even from a distance, the shapes were wrong. The wings were too narrow, the fuselages too lean. These aircraft weren't designed for carrier decks or long over-water missions. They were built for something else entirely. He approached the first wreck slowly, the way a detective approaches a crime scene. It was the most intact of the 5, a single-seat fighter with fabric-covered control surfaces and a radial engine that looked vaguely familiar but subtly different. The faded olive-green paint still clung to sections of the fuselage, broken only by the unmistakable red circles of the Imperial Japanese Army Air Force. Army, not Navy. That alone explained months of confusion. The landing gear had been retracted when it went down. A belly landing. The pilot had tried to save the aircraft. Bullet holes stitched across the port wing told the rest of the story. This machine had been in a fight. The second wreck told a harsher tale. A direct hit from what appeared to be 20mm cannon fire had obliterated the engine. The nose was gone, twisted metal scattered like shrapnel, but the cockpit and rear fuselage were remarkably intact. Guessel crouched beside it, tracing his fingers along control cables that shouldn't have survived such violence. The third aircraft had burned almost completely, leaving behind a skeletal airframe and just enough components to hint at what had once been there. The fourth was missing everything forward of the cockpit, but its wings and control surfaces were undamaged, as if the aircraft had simply been torn in half. The fifth made Guessel pause. Both wings had folded upward, not backward, not snapped cleanly, but bent in a way that suggested something far more disturbing. Structural failure. Not from impact. From stress. From pushing too hard. As the afternoon heat deepened, Guessel worked methodically, cataloging every salvageable component. Engine cowlings. Propeller hubs. Instrument panels. Control cables. Fabric samples. Ammunition boxes. Each piece felt like a clue, fragments of a philosophy made metal and cloth. The ammunition caught his attention immediately. 7.7mm rounds. Light armament. Far lighter than what Allied fighters carried. But the quantities were carefully measured, optimized for sustained firing rather than short, violent bursts. This wasn't about spraying bullets. It was about precision. The fabric covering surprised him even more. High-quality linen, expertly doped, applied with care that contradicted every intelligence report claiming Japanese manufacturing was crude or rushed. These aircraft weren't slapped together. They were crafted. Then he reached the control surfaces, and everything changed. Each aircraft used a split flap system, but not the kind designed for landing. These flaps could be deployed independently, even during combat maneuvers. Guessel stared at the mechanism, turning it over in his hands, feeling the elegance of its design. This wasn't a gimmick. It was deliberate. A way to increase lift, tighten turns, and stay airborne at speeds that should have caused a stall. He had never seen anything like it on a Western fighter. As the sun began to sink behind the jungle canopy, casting long shadows across the wreckage, Guessel made a decision that would ripple through the entire war. Between the 5 aircraft, there were enough intact components to rebuild one complete fighter. It would be difficult. It would be expensive. It would require shipping everything back to Brisbane, commandeering hangar space, machine shops, and men already stretched thin. And it would require convincing superiors who still believed Japanese aircraft were inferior copies not worth serious study. But the alternative was worse. Fighting blind. That evening, Guessel sent a telegram that was as concise as it was dangerous. 5 Japanese fighters recovered. Recommend immediate shipment to Eagle Farm for complete reconstruction. Preliminary analysis suggests new fighter type with unique combat capabilities. Request priority handling. 3 days later, the reply came back. Approved. But remember, Lieutenant, understanding the enemy and defeating the enemy are 2 very different problems. Hangar 7 at Eagle Farm Air Base had never seen anything like what arrived in March of 1943. Wooden crates marked enemy equipment, classified, were stacked like artifacts from another world. The hangar floor became a strange hybrid of archaeological dig and precision machine shop. This wasn't maintenance. It was resurrection. Sergeant Mike Kowalski had been maintaining aircraft for over a decade. He'd rebuilt engines in deserts, jungles, and snowfields. But rebuilding an enemy fighter without manuals, spare parts, or even a clear understanding of its original design philosophy pushed him into unfamiliar territory. The wreckage from Buna was laid out system by system, over 2,000 components tagged, measured, and photographed. The engine became the first major puzzle. The Nakajima HA-25 radial shared ancestry with American Cyclone engines, but the similarities ended quickly. Cylinder heads were different. Carburetor configurations followed unfamiliar logic. And then came the measurements. The tolerances were astonishing. Cylinder bore variations measured in 10,000ths of an inch, tighter than many American engines produced under ideal factory conditions. Intelligence reports describing Japanese industry as primitive collapsed under the weight of hard numbers. 16-hour days became routine. Control cables didn't match American wire gauges. The electrical system ran on 24 volts, requiring complete rewiring. And the combat flap mechanism, Guessel's obsession, had to be reverse-engineered from damaged components and educated guesses. By April, over 3,000 man-hours had been poured into the project. Engineers from across Australia quietly made excuses to observe, drawn by rumors of something extraordinary taking shape inside Hangar 7. As systems came together, a pattern emerged. Everything was about weight. Steel replaced with aluminum alloys. Redundant systems stripped away. Every gram questioned. The finished aircraft would weigh just over 5,000 pounds fully loaded, nearly 2 tons lighter than comparable Allied fighters. It was an engineering gamble taken to its extreme. The combat flaps were the heart of it all. 30 degrees of deployment, not for landing, but for turning. Deployed in combat, they transformed the wing, increasing lift and lowering stall speed to levels Allied pilots would have considered suicidal. This wasn't cheating physics. It was exploiting it in ways Western designers had never dared. Guessel spent long nights studying the cockpit. It was sparse. No luxury. No excess. Engine gauges. Airspeed. Compass. A simple ring and bead gun sight that demanded skill rather than assistance. No armor. No bulletproof glass. No concessions to survivability. Japanese pilots weren't expected to be protected. They were expected to be perfect. And as the reconstructed fighter finally began to resemble something that might fly, a quiet realization spread through Hangar 7. This aircraft wasn't dangerous because it was strong. It was dangerous because it was fragile. By early summer, the fighter sitting inside Hangar 7 no longer looked like wreckage resurrected from a jungle runway. It looked alive. Olive green paint had been carefully matched and sprayed across the fuselage, the finish slightly uneven in places where Allied materials failed to replicate Japanese methods exactly. The red Hinomaru circles were gone, replaced with American stars and bars, not out of respect for symbolism but survival. No one wanted a friendly pilot shot down by his own side while flying an enemy aircraft. Test instrumentation snaked through the cockpit and fuselage, wires leading to strain gauges, temperature sensors, and pressure pickups bolted onto wings, spars, and engine mounts. This was no longer just a reconstruction. It was an experiment, and everyone involved understood the risks. The aircraft had been rebuilt according to Japanese specifications, but with Allied tools, Allied alloys, and Allied assumptions. Whether those substitutions would hold under flight stresses was an open question no one could answer on the ground. The deeper the engineers went, the more troubling discoveries surfaced. During structural load testing, hairline cracks began to appear at wing root fittings under stress levels that American fighters absorbed routinely. The metal itself was not defective. The The design simply operated closer to its limits. Where Allied engineers built in wide safety margins, Japanese designers had shaved those margins down to almost nothing in pursuit of performance. The aircraft could do extraordinary things, but only if everything went exactly right. By late July 1943, the project had reached a point where delaying further would yield diminishing returns. The aircraft was as ready as it would ever be. It was time to fly it. That responsibility fell to Bill Fryer. Fryer arrived at Eagle Farm on August 10th, carrying orders and the quiet reputation of a man who had survived dozens of experimental test flights by knowing exactly when to push and when to stop. He spent 3 days studying drawings, reports, and engineering notes, absorbing every warning the team could give him. He understood the stakes. This aircraft wasn't just another test platform. It was the key to understanding why Allied pilots were dying in the sky. On the morning of August 17th, Brisbane awoke to clear skies and calm air. Perfect conditions. At 0730 hours, Fryer walked toward the unfamiliar silhouette waiting on the tarmac. The fighter looked lean, almost delicate, its proportions alien compared to the rugged bulk of Allied machines. It seemed less like a weapon and more like a blade, thin, sharp, and unforgiving. His pre-flight inspection was slow and meticulous. Control surfaces moved with astonishing ease, almost too easily. The fabric felt taut but insubstantial beneath his hands. The landing gear, lighter than anything he'd handled before, inspired no confidence in rough handling. Every step reinforced the same impression. This aircraft did not forgive mistakes. Climbing into the cockpit felt like stepping into another philosophy of war. The seat was simple. The panel sparse. Instruments were placed where Japanese pilots expected them, not where Fryer's muscle memory wanted them to be. Most unsettling was what wasn't there. No armor plate. No bullet-resistant glass. No protection at all. Engine start at 0800 hours was anticlimactic. The Nakajima radial coughed, caught, and settled into a steady idle that sounded almost friendly. During run-up, subtle differences emerged. Throttle response was immediate, almost nervous. Carburetor heat behaved differently. Temperatures rose and fell faster than expected. Every input required attention. Taxiing revealed the aircraft's first warning. It was too responsive. Small rudder movements produced sharp directional changes, forcing Fryer to constantly correct. This was an aircraft designed for pilots trained to live inside it, not adapt to it on the fly. Takeoff erased any lingering doubt about its performance. The aircraft lifted off in less than 800 feet and climbed like it had been released from gravity's grip. 2,000 feet per minute. Then more. 3 minutes after liftoff, Fryer was already passing 8,000 feet, staring at numbers Allied pilots would have called exaggerated if reported in combat. But the climb came at a cost. Every gust of air translated directly into motion. The aircraft felt alive in a way no Allied fighter ever had. It didn't dampen the air. It transmitted it. Level flight at altitude told a more complex story. At cruise power, speed settled around 280 miles per hour, respectable but not dominant. It wasn't faster than its enemies. It didn't need to be. The moment Fryer deployed the combat flaps, the aircraft transformed. The stall simply disappeared. Airspeed dropped below 90 miles per hour, yet control remained absolute. Turning circles tightened to absurd dimensions. The aircraft carved through the sky like it was hinged at the wingtips. It wasn't flying the way Fryer understood flight to work. This was the secret. Japanese pilots weren't outturning Allied fighters through bravery or luck. They were flying a machine that bent the rules. But physics always collects its debts. During high-G pullouts from simulated diving attacks, vibrations crept into the control stick. Wing flex became visible. Fabric rippled in ways that made Fryer's jaw tighten. This aircraft could perform miracles. Briefly. Push it too hard, and it protested loudly. The warning became impossible to ignore during mock dogfights against a Spitfire flown by squadron leader James Mackenzie. Below 15,000 feet, the rebuilt fighter could outturn the Spitfire at will. Mackenzie couldn't stay behind it. Every turning engagement ended the same way. The Japanese fighter simply pivoted inside the Spitfire's circle. But the moment Fryer tried to sustain those maneuvers, the airframe began to complain. The decisive moment came during a simulated head-on pass. Fryer pulled hard to avoid Mackenzie's guns. At roughly 4.5 gs, the aircraft groaned. The sound wasn't subtle. It was structural. He immediately unloaded the wings and terminated the maneuver. Post-flight inspection confirmed the worst fears. Stress cracks at wing attachments. Exactly where the engineers had predicted. Landing was gentle, almost effortless. Touchdown occurred below 70 miles per hour. The aircraft rolled to a stop in less than 600 feet, performance that explained how Japanese fighters operated from jungle strips Allied aircraft couldn't even consider. But the ground handling remained twitchy, demanding constant attention. Fryer's report was blunt. This aircraft was extraordinary and dangerous. It could perform feats no Allied fighter could match, but only by operating dangerously close to structural failure. It was like flying a paper airplane with a razor's edge. In September 1943, the rebuilt fighter was loaded into a transport bound for Wright Field in Ohio. There, under the scrutiny of America's most advanced testing facilities, its secrets would be extracted completely. And those secrets would change the war. The C-54 touched down at Wright Field on September 23, 1943. Inside the hangar, the rebuilt Nakajima K43, the Oscar, became the centerpiece of the most comprehensive enemy aircraft evaluation in American history. Colonel Harold Watson oversaw the project personally, assembling a team of test pilots, engineers, and intelligence officers determined to extract every ounce of tactical and technical knowledge. The Oscar was dissected in every possible way. Baseline performance tests measured speed, climb, ceiling, and range. Wind tunnels simulated airflow over its wings. Strain gauges and instrumentation collected data on structural loads during every conceivable maneuver. Nothing was left to assumption. Every movement, every vibration, every note of stress was recorded. Initial flights confirmed what Fryer had discovered in Brisbane. The K-43 climbed with astonishing rapidity, reaching 20,000 feet in under 8 minutes, surpassing the P-51 Mustang by nearly 2 minutes. Maximum speed, while respectable at 308 miles per hour, was not exceptional. Yet speed was not the aircraft's weapon. Its true advantage lay in maneuverability. Engineers confirmed that the combat flaps were the secret. When deployed during turns, the flaps increased the wing's lift coefficient by 37%, maintaining airflow at angles that would stall conventional aircraft. This system explained how Japanese pilots executed sustained turning maneuvers at speeds that Allied pilots had thought impossible. It was brilliant aerodynamics, elegant, and completely alien to Western design principles. Yet, the wind tunnel also revealed the compromise. At speeds above 250 miles per hour, flap deployment stressed the wings beyond safe limits. The aircraft forced pilots to choose between maneuverability and structural safety, a trade-off Allied aircraft never demanded. Armament analysis told another story. Two 7.7 mm machine guns, each with 450 rounds, represented minimal firepower compared to Allied fighters, which boasted 6 to 8.50 caliber guns. The Japanese relied on precision, training pilots to make each shot count, rather than overwhelming an enemy with volume. Their philosophy was simple: skill over firepower, finesse over brute force. The Nakajima HA-25 engine revealed sophistication unexpected by Allied intelligence. Cylinder tolerances exceeded American standards. Metallurgy used advanced alloys, contradicting assumptions that Japanese industry lacked strategic materials. At 925 horsepower, it matched or exceeded many Allied designs, particularly at mid-range altitudes. Its range, however, was limited without drop tanks, just 400 miles internal, emphasizing defensive operations close to Japanese-held territory. Controlled combat comparisons cemented the Oscar's strengths and weaknesses. Against the P-40 Warhawk, it climbed faster, turned tighter, and dominated low-speed engagements. The Warhawk's superior diving speed, structural strength, and heavier firepower offered countermeasures, but only if pilots knew how to exploit them. Against the P-51 Mustang, the gap widened dramatically. The Mustang could engage and disengage at will, rendering the Oscar's turning advantage less meaningful. Intelligence officers interviewed captured Japanese pilots, using interpreters to understand training and doctrine. Each pilot averaged 400 hours of type-specific training, nearly double what Allied pilots received. The intense preparation was necessary to exploit the Oscar's performance without collapsing the fragile structure. Pilots were taught to hit fast, climb quickly, and disengage before Allied aircraft could capitalize on superior firepower. Sustained dogfights were discouraged, permitted only under favorable numerical or positional circumstances. By November, the Wright field team completed a classified report that revolutionized Allied understanding of Japanese air power. The Oscar's extraordinary maneuverability was real, but it came at a steep cost: structural fragility, minimal armament, and dependency on highly trained pilots. The aircraft had evolved as a response to resource scarcity and Japanese operational philosophy, prioritizing pilot skill over mechanical resilience. The intelligence filtered down to frontline squadrons in early 1944 through tactical bulletins. Captain James Watkins of the 9th Fighter Squadron received Technical Intelligence Bulletin No. 47 on March 15 while stationed at Buna Airfield, New Guinea. The document outlined precise instructions for engaging the Oscar: abandon turning contests, exploit superior diving speed, fire brief, accurate bursts, and disengage. Speed and firepower replaced skill as the dominant factors. Watkins' first test came in August 1944 over Huan Gulf. 4 P-38 Lightnings encountered 12 Japanese fighters at 15,000 feet, a fight that would have been suicidal under old doctrine. Following the new tactics, Watkins led a high-speed diving attack, concentrating firepower during brief engagement windows. 2 Oscars disintegrated under concentrated fire, a third was disabled. The remaining Japanese pilots attempted to climb and re-engage, but structural failures claimed 2 more aircraft. The remaining fighters retreated. Victory was decisive and methodical, not miraculous. Other squadrons quickly adopted similar approaches. P-38, P-40, and Spitfire units across the Pacific used hit-and-run tactics, diving attacks, and firepower concentration. Kill ratios reversed. Units that once lost 3 or 4 aircraft for every Allied plane now found parity, even advantage. The Japanese air war, once dictated by legendary pilot skill, now faced strategic countermeasures grounded in engineering reality. By late 1944, the impact was undeniable. Experienced Japanese pilots struggled to exploit their aircraft's maneuverability against opponents who understood its weaknesses. Replacement pilots, lacking experience, suffered catastrophic losses. Japanese training units reported accidents in which aircraft wings failed under routine maneuvers. Structural compromises that had gone unnoticed in early years now proved deadly. Lieutenant Clyde Guessel, whose observation at Buna Airfield had set this cascade of discoveries in motion, could finally see the fruits of his work. From twisted jungle wreckage to the classrooms of Wright Field and the skies over the Pacific, Allied understanding had caught up. Knowledge had replaced superstition. Engineering intelligence had transformed tactics. The Oscar, once feared as invincible, was now an adversary whose capabilities could be anticipated, challenged, and neutralized. The Pacific theater would continue to rage, but the balance of knowledge had shifted. Allied pilots now approached combat with data instead of myth, tactics instead of desperation, confidence instead of fear. The reconnaissance and reconstruction efforts of a single lieutenant, combined with the ingenuity of American engineers and test pilots, had turned the tide in aerial combat. And in the silent hangars of Wright Field, the resurrected Oscar remained, a testament to the power of understanding, the danger of assumptions, and the truth that even the most feared weapon could be tamed by knowledge.